Oh, I let my nightmares go. I put on everybody that I knew from the go. I know hoes that was frontin' when they knew we was broke. They say, damn, easy, easy, he don't love us no more. I got that big fame, homie, and you just changed on me. You can ask big homie, man, the top. Sure lonely I lie. All right, anyway. Yeah, I didn't know I had it like that. Welcome everybody back to the Swift and SwiftUI Learnalong. Buddy. We're about to move past the Swift part. So this is episode, where are we at, Jer? What are we on? 43? 43, yeah. This is episode 43. Pardon my my windedness, brother. Got started a little late, moving around fast. Ooh, and then I threw back I chugged a venti mocha frap with 3 shots. Obviously no sugar pumps added, brother, but I'm feeling my shit's like fucking shaky, you know what I'm saying? So yeah, but that's a good thing. So that means we should be in for a long stream, but goddamn. Ooh, strong stuff. Okay, but anyway, for the uninitiated, I'll do this intro very quickly. This is the stream where, true to its namesake, Learn Along. This is me actually reading a book. So if you like story time, this is a lot like that. Reading you this very amazing book that I highly recommend that you go grab. Swift Programming, The Big Nerd Ranch Guide, 7th edition. So I read it to you and to myself because this is me learning it for the first time. This isn't me making content for the viewer's purpose exclusively, if that makes sense. So that's the reason why it's not going to be your typical, at least from what I've seen other people streaming, you know, they're interacting with chat. Oh, what should I build here, brother? No, I don't really know it like that yet, but we're learning it for the first time on this stream. Hopefully together, because this entire book has been, like, I haven't done any learning from this book off stream, which it's pretty cool because now, you know, 43 episodes in, that's about, well, it's basically about 120 hours of content just from this book. So, and it's a big one. It's 818 pages, but we literally covered every aspect of the Swift language. So it's been quite the ride. But anyway, after we get through this, so we're on the tail end. So let me show you. We are, we're now at the app, just writing app stage, but we've moved through everything. So you can see we're on the very last chapter. After we get through this today, we will roll into SwiftUI specifically. So SwiftUI is a framework open source by Apple, 100% in Swift, and it's for writing GUIs, your graphical user interfaces. So I actually saw a really cool thing. I don't know what you would even call it yet. I guess it was a library as a way to generate HTML with Swift. So I really want to get into that. So after SwiftUI, we'll look at that too. So you can use Swift to build your web interfaces as well, which is a joy for anybody that's ever written JavaScript, HTML, CSS, you know. Anyway, we're going to get there. We're going to go through the SwiftUI course. So much of the same fashion, you guys will learn along with me as, you know, fly on the wall style. And then after that, we'll do some app design. So I need to do some schema design for I'm going to have a SQLite local storage for my app that I'm thinking. So I started a company. So this whole stream is all in a effort to build my first product for my startup, right? You know what it is. No, really though, it's called Nodtech Systems. Okay. And the first product is going to be called MRP Panda. MRP standing for Material Resource Planning. And so a little bit about me. For the past 10 years, I worked for a service company that resold an ERP system, an ERP, Enterprise Resource Planning. That's not really, it's kind of a bullshit term, but SAP, Microsoft Dynamics, Sage, those kind of programs that, you know, businesses would use to manage their books, the GL, their purchase orders, accounts payable, you know, inventory systems. So that's what we did, and we also had an in-house product. So all of our customers were specifically food manufacturers, and food manufacturers have kind of been going through it since '08. Whenever, I think it was '08, when Obama passed FSMA, which was the Food Safety Modernization Act, which introduced this notion of, maybe you've heard this term, farm to fork, cradle to grave. It just means that any manufacturer, take a hot sauce manufacturer, for example, because that was one of my accounts back in the day. So if they buy pepper and salt and, all manner of spices, and then they end up, because they were cooking massive kettles, 5,000 gallon kettles of hot sauce, and then it gets distributed. So their customers are the grocery stores or the U.S. Foods. Like, you've probably seen the U.S. Foods trucks flying everywhere down the highway. That's who they would sell to. So the retail customers weren't necessarily their end customers, but that's irrelevant. The point is, for every single piece of material, raw material, that came into that warehouse, whenever they receive it, there's a lot number that's associated with it. It's a unique lot number, and it'll have, say lot number is 123, and it'll say, okay, there's 20 pounds of pepper associated with this lot number. So all throughout the process, when they're building all this stuff and mixing all this stuff, they would use our software or other softwares like it to tell the system, this is what we're creating. So we're taking all these ingredients. We need to take all that out of inventory, and we're creating this new product, this finished good. And so in the event of a audit or an actual recall, they have 4 hours. So an auditor will go out into the warehouse, pick a random lot number, because most things should be barcoded at that point. But even if not, just find some random lot number, and he'll tell you, I need to see everything about this within 4 hours. And if you don't pass, you can get shut down. So, I mean, it's not a game. Let's just say that. It's not a game. But now the traceability aspect is, I felt like we've fairly well solved it. There's good, paradigms for that now. So that's not really the issue. But on the flip side of that, the inventory management and the ability to forecast and kind of play with your data, or have your data teach you what your next practices should be or what you should focus on, kind of like A/B testing from a customer standpoint perspective. Like, if you're trying to, like, maybe you've grown to a certain point, maybe you started out, mom and pop shop, now you're doing 5 million a year. It behooves you to focus on your larger customers and stop doing little mom and pop orders, as shitty as that sound, but that's life. And so that's the kind of insight that the application is going to seek to provide in terms of when, where, how you should buy your inventory, accounting for sales demand, letting the sales demand tell you based off of your recipes how much time you're going to need, how much transit time you're going to need for your vendors to get it there based off the shipment date. So a lot of cross analysis, right? We're going to talk about it, so I don't want to say too much about it, but it's a very common problem. It's a very common problem. So I don't assert that I can solve all those problems with one app, but I do think I can solve a lot of those problems specifically for food customers, because that's where my experience lies. So that's the goal. That's the intent of learning all of this stuff. I really like Swift. I wasn't sure if it'd be the right language, but I'm actually very pleased with what we've learned. It is extremely expressive, and I think that's the main draw here, between the protocols, classes, and the structs, and the things you can do with enums and the control statements with your switch statements. Yeah, it's pretty impressive. Pretty impressive. Now, in terms of what my experience level was before this, I wrote SQL for 10 years, so I would say expert level at that. But aside from that, Golang and JavaScript, I would say I'm a journeyman, an adept, certainly no expert. I'm no expert at that. So a lot of this stuff is new. A lot of the concepts are new, especially because Swift is just so different than Go in many ways, and JavaScript, obviously. But yeah, that's the general sense. So if that sounds cool, then stick around. If not, get the hell out. No, I'm playing. But you can leave, though. Now, where were we? Chapter 28. The last chapter. iOS and macOS apps. Actually, I need some water. My heart is beating at like 15 billion beats a second. That Starbucks, buddy. Man, maybe I'll cut it back to. Woo. I might have to go jump over a building real quick. Okay. Swift is a versatile language that is used to develop apps for all Apple devices, from iPhone to Mac. Oh, by the way, Swift released in 2014. Isn't that crazy? And comparatively, that's still a pretty young language. So it's a decade old this year. And it's still considered a pretty young language. Like by comparison, like Golang, for example, 2007. Rust 1.0 and well, I think that was 2015, so it's a little bit younger, yeah. Yeah, anyway, that's just an aside. As you saw in the last chapter, you can use it to write tools for use at the command line. In this chapter, you will write an app for iOS and macOS using the SwiftUI framework, which comes with Xcode. Okay. SwiftUI includes types used to describe visual elements like buttons, colors, text, and images. It also provides the machinery for reacting to user input, such as the user typing text or tapping a button. SwiftUI is a large framework, and iOS and macOS application developers are large topics deserving of their own books. Wait, SwiftUI. Oh, development, not developers. Development are large topics deserving of their own books. This is true, and just FYI, speaking of next books, I didn't say that in the intro, but just to quickly fix that. After we do the app design and the schema design that I talked about, we're going to roll right back into another book from the Big Nerd Ranch, specifically on iOS programs. So this one is specifically focusing on Swift, the general purpose programming language. The next book that we get back into will focus on the Apple APIs, which is one of which is SwiftUI. So we're talking about that now. But yeah, just so you know, that is what we're doing next before we actually start building the thing. Because yeah, the Apple APIs are a language unto itself. Okay, this chapter aims to whet your appetite to continue your learning journey by showing you how far you've come and what you are ready for. Yeah, okay. To keep you on track in your journey, you will build a multi-platform to-do list app called Tadoodle. Running it on macOS requires macOS Big, whatever. However, most of this chapter is focused on the iOS version, which you can run in the simulator app that also comes with Xcode. Okay. Okay, so this is what we're building. Okay. Getting started with Tadoodle. Begin by creating a new Xcode project. All right, brother. Let me just... I still can't manage to... Maybe it'll work that way. Okay, so it worked. Okay. Let's say I've still yet to manage to quit Xcode without having to force kill it. And there you go, for the very first time. All right, so then... oh, I lost my instructional. Unlike previous projects, this will use the multi-platform app template. Okay. The multi-platform app. Name it Tadoodle. Leave the use core data and include unit test options unchecked. Okay, I don't see those, but oh, they're probably on the next screen. Okay, so app, Tadoodle, and use core data. I still don't see that. I'll wait till the next screen. As with the other projects that you have created, you will find that the template populates your navigate area with some files, in addition to some supporting files. Oh wait, it's already moved on, so let me just finish this screen. Swift. Yeah, a lot of this must have changed because they don't mention any of this stuff, but I'm going to assume we want SwiftUI, so I'm going to pick that. Storage. Wait, what's on the next page? They don't tell you. Let's see. Because you're... Okay, we'll have to guess then. That's all it says. That should be all right. We can always just make a new one, so... Next. Here's fine. Okay. Get out of here. Yeah, so this is pretty cool. I mean, this was one of the reasons why, actually probably the biggest reason why I chose Swift, because I saw what this could do. Meaning, I don't know if you guys have ever written a web app with any of the more modern frameworks, you'll be familiar with the, what do they call it? HMR, hot module reloading, which basically means as you type code on the left here, on the right, it'll react to it. So visually, you can constantly see what your code is doing, or if you've broken it, you know, because your image would just die. But that to me is wildly helpful. Some folks don't prefer that. I mean, they can just write the code and that's cool. That's great. But I like this a lot. I like being able to see, because then you can iterate more quickly. Not so much for as a correctness check, because the compiler can do that for you, but just to be able to make decisions on the fly and actually verify that it looks the way that you intend, I think is invaluable for sure. So I'm not really a fan of the drag and drop type tools, like the low code stuff. That's bullshit, and it's just not viable. But this kind of thing, I think, is awesome. Okay, so as with other projects you created, you will find that the template populates your navigator area with some files. Let's go look at those over here. Okay, so we got our to-doodle app.swift file, a content view, assets file. I'm not sure what that does. XC assets, todoodle.entitlements. Never seen that either. And preview content. Okay. In addition, some supporting files for managing app metadata and supplemental assets such as icons. There are two Swift files, todoodleapp.swift and contentview.swift. At the heart of SwiftUI app development is the idea of a view. Okay. And a view is a visual element. Visual element. SwiftUI defines many types of views for displaying text, images, and even groups of other views. You will define some of your own. Okay. Because views are so central to SwiftUI, Xcode changes its interface when you are editing a view type. A view type. Open content.view. All right. Oh, so how does it know? I guess it'd be obvious because of type view or by the file name, one of the two, but it knows somehow, so that's cool. Okay. Then, because views are so central to SwiftUI, Xcode changes its interface when you're editing a view type. Open contentview.swift and click on the line of code that contains text. Hello world, line of code, okay. Okay. The graphical representation on the right-hand side of the editor should update to reflect the selected object. No. Do I gotta go to insert mode? Is that why? I mean, nothing's happening at all. The graphical representation on the right-hand side of the editor should update to reflect the selected object, as illustrated in 28.3. If you do not see the graphical representation, click the resume button. The resume button. Let's just look at this real quick. Hold on. Build and run, scheme selector, resume button, editor options, toggle inspectors. Oh, good, zoom. Okay, that's really what I wanted to find. Okay, well, I don't know what or why it's not highlighting, but everything else looks right. This should reflect if you do not see, click the resume button. Where's that at? Resume. I don't have that button. Is that what this is? What is this down here? Fucking click it, man. What is it doing? Okay, my bad. Sorry, I lost my patience just for a second. Okay. I don't know what it's doing, so we'll just move on because clearly Xcode must have updated stuff since this book was written. But the book is for 5.8, and now we're only at 5.10 now with Swift, so oh well, but we'll deal with it. So you've already encountered many. Wait, what did this say? Indicated in the screenshot. If you see an error message regarding cannot preview this file, make sure the scheme selector above the editor is set to tadoodle. Maybe they just made it simpler because I'm already seeing it, so maybe that's what they meant. Oh no, yeah, they have the blue box around hello world. Whatever, brother, it ain't. Can I run this? Does that wake it up? Preview paused. Running to doodle. Oh. So I get it here and in a separate. Oh well, I don't know. They're saying there should be a blue box around hello world whenever we select the actual code, which I've seen it do before, just dinking around. But we've seen how kind of, I don't want to say janky, but inconsistent Xcode can be. So we'll just give it some time to think about what it's doing. All right, you've already encountered many of the important parts of Xcode's interface, such as the navigator area editor, run button, and scheme selector. As you dive into app development, close this. As you dive into app development with SwiftUI, there are some additional areas you should know about. The canvas provides the canvas provides a live updating rendering of your views. Okay, so this thing on the right, which is very cool, with the editor options button. Wait, you can show and hide the canvas with the editor options button above the editor area. Okay, so over. Oh, okay. Show editor only, canvas. Okay, easy enough. Editor option above there. Check or uncheck canvas in the pop-up menu. The layout option in the same menu allows you to set whether the canvas is to the right of the editor or below it. Oh, maybe that might be better for. Yeah, that might be better. For the grammars. Because this will be hard to. Yeah, that's good enough. Okay. So then. Now what? When you make large changes to your code, the canvas will pause updates to the preview. When it does, you can click the resume button to begin updating the preview again. Yeah, thing is, I don't see the resume button. It must be this little play button. And what does that do? This is. Oh, that's how you do that. Okay. So now when I click in Hello World, it highlights the Hello World in the little preview. All right. I guess I could zoom in here. We're doing it, man. What do you think of our app? Oh man, looks like a little watch app. When you click the resume button. Okay, so whatever this, I don't know if y'all can see that. It's like kind of hidden down here. So I just selected that little blue arrow, which they refer to as content view. It's supposed to disappear after I leave it there for a second. Let's see if it's working. There we go. Yeah, so I just clicked on that, but all right. So what is this? Color scheme variants. Okay, I don't want to do that. And what is this here? Canvas device settings, color scheme, defaults to dark. I guess we'll leave it on dark. So this view, this little play button must just be, it's constantly reloading. And this is select table. Yeah, either way, we know how to get there. Okay. If your preview is uncomfortably small or large, you can resize it with a pinch zoom gesture on your trackpad or with the zoom control in the bottom right-hand corner. Okay, we saw that. The attributes inspector, the rightmost tab of the inspector area with an icon that looks like whatever the hell that is we did see that though. Where'd it go? Or not. That's not it. Yeah, this thing. Although no selection, why not? Well, that's the button. I don't know, it should appear over here. Identity and type. Quick help. Oh, that's badass. Oh, are you kidding me? Oh, I love that, man. I don't know if y'all can see that. It just has quick access to the official docs built in based off whatever type of thing you have highlighted. Man, I love that. Okay, so what is this? Accessibility. Okay, here we go. Now it's showing. So let me see. I don't know if y'all can see that. It's popping up over here. Actually, I'm going to stretch it full screen. Better yet, if hold on, let me check something real quick. Let me get my. I meant to add this before here. And yeah, okay. So that's what that is. Let me put this on. Copy. I just want to add something here. Duplicate. I just want a text box. I'm trying to add this and put this in that empty space so anyone that sees this can just go watch on X. Add a new source. Watch on X. Okay. Wait. Watch this stream. Nor oat. Yeah. And where did it go? Right there. No, 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 no. This is so tiny. Ah, shit. Almost there. Yeah, a little ratchet, but you know, it's undo what it do. And then over here, we will just hide that bad boy. Hide. Or no, it won't let me. Come on, man. Delete. Yes. God damn it. Okay, that's good enough. Well, where did it? Oh, it's over there. So bring it below. Okay, good. All right, so where are we at? Yeah, so I'm just gonna leave it as is, and then if you want to see it full screen, you can watch it on X. It's on Twitch. It's on a bunch of places, but I assume X would be the most prominent thing after Instagram. Maybe more so. I'd be curious to know that. Probably is, actually. And by some margin. Twitter is kind of like, or X is kind of like part of the culture. Even the presidents use it. Instagram's more for, thoughties, thoughties and except for me. If your preview is uncomfortable, oh wait, we read that. Okay, attribute inspector. Okay, we saw that. Where did we leave off? Okay, yeah. The attribute inspector, the rightmost tab of the inspector area with an icon that looks like the little 3 bars, allows you to configure the currently selected view. We encourage you to experiment with the attributes inspector and the other inspectors, but most of this chapter will focus on code. All right, you can hide the inspector area anytime with the little close button at the top right of the Xcode window. Okay, so we got that. In the editor's code area, change the string text from hello world to hello SwiftUI. Okay. Keep it simple. Hello SwiftUI. Cool. And watch the canvas update. You may need to click the resume button. I did not, brother. Your app will run in both iOS and macOS environments, but for now, you will test your application in Simulator, a program that ships with Xcode to simulate the experience of using an iOS or watchOS, etc. device. Kenyan Beast. From the scheme drop-down menu, move to the To-Doodle iOS submenu and select an iPhone to simulate. Oh, okay. Here, brother. To-Doodle. I just feel like did I not pay for something? I mean, why am I missing all these buttons that they have? What the fuck? Yeah, it's iOS. This says it's the scheme selector. Yeah, I hope they don't change it this much every year. That wouldn't make a ton of sense, but as with the other things, guess we'll just have to wing it. So what am I trying to get to? From the scheme drop-down menu, move to the To Doodle iOS submenu. So I'm going to go back to the code view, go to scheme. Where would you scheme? To Doodle. Choose scheme. Edit scheme. I've seen where you can choose that, but canvas, editor, scheme, drop down, move to submenu, simulate. Let's just go through every single menu. How about that? Fuck. File. Not likely one of these. View. Editor, no. 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 Not find, not navigate. Canvas, no. Minimap, authors, code coverage. My plugins, nope. Product, build for, no. Maybe it's new scheme. No, that's the same fucking. Maybe it's within the thing itself, but simulate location. Oh no. Integrate? No. Window. Xcode help. Ay. Okay, so I guess I gotta find scheme. Scheme of the URL, no. Modify, no. WebKit. No. Dude. Maybe I didn't download. The Oracle should be able to help. In Xcode, wait, what version am I on? That is one thing I'll make sure to do next time. If possible, get a book that uses my editor version, or just not update the editor, because I have, since we started this book, they've released 2 updates to Xcode, so maybe that's why. Where is the about? Develop, no. Oh, about, there you go. 15.4. All right. And Xcode 15.4. How can I change my scheme to iOS such that I can select a iPhone to simulate? Follow these steps, they say. Select the target device. In the top toolbar, locate the scheme menu, which is next to the play and stop buttons. Build. Fucking where? It's not next to the play and the start buttons, man. What is this? Is this it? This is the Git branch. Damn, it's still going? Yeah, Jesus. Okay, so can't stand this. You'd be amazed how much fucking time is wasted doing shit like this day to day. And it's not, I mean, it's not just Apple stuff or Swift. This is like everything, but still, it's really fucking annoying. Select the target device. Top toolbar, locate the scheme menu, which is next to play and stop. It displays the name of your app and the current target. Okay, so that's this thing. Way up here, okay? Okay, so they moved it to the very top, and then what? Click on the target device, open the drop down. In the drop down menu, you'll see various options under different categories. Okay, so maybe that's the issue because I have no other options here. Ensure the device is unlocked and attached with a cable or associated. What for fucking? Oh, okay, simulators. There you go. So I guess you have to enable these or something. So which one did you want me to pick? iPhone SE 2nd gen. Ancient, brother. That shit came out years ago. They ain't even got it on the list now. Guess we'll do 3rd gen. Okay. These appear to be all exactly the same. Listed 3 times. All right, so I just picked the top one. Automatic. Yeah, fucking show it, dude. What do you mean automatic? How would it? Always. Always. Actually, yeah, maybe I don't want to do that to a ton of them, but this works for now. And they're still not there. Why? You have to restart iPhone 3rd. Probably. If this doesn't work, we'll just restart it and close that. Son of a gun. Okay. Quit. All right. I'm gonna lose it. All right, so let's try the next thing because that shit ain't working. We at least see the list. Choose an iOS device. Set the selected device as the active scheme. Target device in the scheme menu. If you don't see the desired iPhone model, Xcode settings, preferences, components. Oh my gosh. Settings. And then components. Which there is not. And how the fuck does all the terminology change across 2 updates? It's so fucking irksome. Yes, yeah. Yeah, for sure. Editing, no. Key bindings, no. Probably platforms, iOS. So I have some, but even these didn't show up. This one's already on disk. What the fuck, man? Let's just see what I can. It's just one per platform, so iOS. I don't know. Re-download maybe? I guess it's possible that it's not there because I did change drives, so maybe it just didn't update that. Like if you change the drive, but you already downloaded it in the cache somewhere, it just stores that you did download it, but it's not like checking for if you then remove the drive or whatever. So hopefully that's it. That's the only thing that would make sense because it's telling me it's already there, but clearly it is not. But yeah, these are pretty big. The cool thing is, maybe I'll do this if this doesn't work, but I mean, if you have an iPhone or an iPad, whatever, you can run your simulation on the device directly, the physical device. So you can use your iPhone to develop stuff. You don't necessarily have to use the simulator, but I would like to use what they're asking me to use if I can get it to fucking work. I think all in all, I mean, so far, my issues with, let's see, well, this is downloading. We got time anyway, brother. Let's see, my issues with, make that a little bigger. I have this much time to bitch about it while it downloads. And here, don't delete it. Okay, my issues with Xcode so far. Frequent updates, moving UI around. That's really fucking annoying. And I'd even call kind of goofy within the span of a year's time. I mean, how can it change so much? But clearly, this book was using Xcode at the time, so it's like a snapshot of what it was. We can see what it is now, and it's very different, and that's really it's fucking annoying. What else do I not like about it? Probably that. Oh, this is a big one. I don't know if this is really Swift or Xcode, but I'm going to put it here. Project config is editor based, not in code. I don't really like that. I really don't like that. Because then you have it's just nice when you, at least if the source code itself can move around and still be functional. I don't think it should have ties to the particular editor, but in this case, like with the command line tool that we created, designating it as a command line tool change the behavior of the main Swift file. So you can't really take that anywhere else, I would assume, in terms of editing and have it function the same. Or how do you then amend that? What if you don't want your project to be command line tool? There's lots of questions I have about how some of that stuff is going to work. Every other language that I've encountered has not had, what are we at? 38%. Every other editor that I've come across has not had that kind of tight knit dependency between the actual source code and the editor itself in terms of controlling the behavior of your project. So that's a bit odd to me. Although maybe that shouldn't be too surprising given it's an Apple product, but because all their stuff is so tight knit. But yeah, I knew what I was getting into going into it. I just didn't know the specifics. But you use Apple products long enough. Better yet, if you use Apple products and then try to either integrate other products, like, something from Samsung, or if you just try switching altogether, then you get very quickly you get a sense of how, they call it the walled garden, Apple's walled garden, their ecosystem. You really quickly get a sense of how much they want to protect that. Because, yeah, I mean, they let other things, like, for example, I can use my earbuds, or what do they call them? Galaxy Buds Pro, sorry. The Galaxy Buds Pro, great headphones. I love them. You can use them on the iPhone, but it basically cripples them. It can only do very basic things if you use them on the iPhone. It's stuff like that, but they do it everywhere. With the file system, with external drives, with Bluetooth, with mice that are not Apple mice. Especially the iPad too, which pisses me off because I love my iPad. I love my iPad, but yeah, that shit's annoying. Very, very annoying. Apparently they said that the VS Code, what are we at now? 60%. All right, come on, I gotta talk slower. I'm stalling, baby. No, but the visual, or I can't even talk. The VS Code plugin for Swift apparently has gotten a facelift and can do some of these HMR real-time reloading, some of the debugging. So I'm interested to see what that might be like. Well, I think we'll try that. We'll do this portion in Xcode since we're already in it. You can get a feel for my pain and suffering, and likely the pain and suffering you'll have to some degree. Should you choose to do it yourself. But I think it's good to see some issues up front so we can just troubleshoot them, and then we'll know, what the problem is. Because eventually, if we spend enough time here, meaning like in Xcode, we'll find out where the stuff is, and then it should smooth out. But, it's fun to bitch and moan up front. All right, so where was I? I was bitching and moaning. Okay, so project config is editor-based, not in code. It's not very clear, but that's okay. And then what else did I not like? Oh yeah, the build times. Build times are slow. Now, comparatively, or rather, I'm saying that in a comparative fashion or a relative fashion to my only other touch points in programming, which was Golang and JavaScript. JavaScript, of course, is not a compiled language, so that's not the comparison. But Go is a compiled language, and it's fucking fast. I mean fast. And in this case, like the Xcode build, whenever we're watching it here, if you think about it, we're only compiling 60 lines of code, and it takes about 7 seconds. Go would do it in like less than, I don't know, like a quarter second, under a second for sure. I mean, it's very, very fast. And that was part of the design. That was intentional because it was built as a response to C++'s very slow compile times. I mean, the authors said that themselves. I'm not just pulling that out of my ass. But so, I mean, there's a reason that it is very fast. Also, I know the big difference is like Swift is built on top of LLVM, which itself is like a framework for building compilers and doing optimizations. But the cost of those optimizations, the code optimizations, is the slower compile time. So, you're always making trade-offs, but yeah. But what's interesting, the dude that wrote or that created LLVM is the same guy that authored Swift. Pretty cool. That guy is quite impressive. He's the same dude that authored, if y'all have heard about it, Mojo, the new programming language. It's not 1.0 yet, but you can use it, and it's effectively shooting to be the de facto programming language for AI, because they've taken Python, it's a superset of Python, and they've also added additional syntax and paradigms for working with modern hardware, distributed systems, things that if you're working in machine learning or deep learning or even like generative AI, neural networks, any of that stuff really with distributed systems, its syntax built around for that to accommodate, all the new crazy upgrades that we've had with hardware over the years, as opposed to using, things like C or Python that are single threaded. They weren't designed initially to be multi-threaded or to utilize multi-core systems. And so anything that's added on after the fact to those older languages is kind of, it's a little jank. It works, but it's a little jank. Installing. Okay, good. So it looks like, I guess I'll quit bitching now, if this works. But it's saying it's installing, so it hopefully holds that it was in fact deleted by me changing disk, and then the Xcode thingamabob just didn't realize that. But hopefully this is all we need to do. And I'm gonna go pee real quick. BRB, brother. Dang it. Why isn't it popping up? Oh, there we go. BRB. Is it as big as it gets? Oh well, yeah, I'll be right back. That was a waste of time. Care for you. Kuna Matata. What a wonderful rave. Means no worry. All right. It's done, brother. It's there. And hopefully it just works now. Motherfucker. Well, I think it's fair to restart again after that. We'll see if that's the deal. Maybe I need to now add it again. What gives, man? I might just have to plug in the old phone. Now there's 4 of them. How about you here? Edit scheme, new scheme, manage schemes, auto create schemes. Oh my god, dude. Okay, fine. Auto create. What does that do? Nope. I don't fucking get it. Let me just try it. I'm gonna plug in my phone. Hold on one sec. Never mind. I just realized I can't fucking do that because then how will you guys see it? And that's really fucking annoying, and this should just work. So we're just gonna suffer and suffer and suffer until we can figure it out. Click simulators tab. So this isn't working, so maybe I did not set up the project right. I downloaded the iOS sim. It restarted Xcode. I still do not see. Oh, I gotta tell it. I did literally everything, or else it'll tell me to go try the thing. Added it in Xcode. Restarted. Still don't see the iOS Optoin option popping. Popping. Could it be related to my project? Okay, deployment target. Go to your project setting. Scoot you over a little bit. There. Okay, go to project settings, click on the project name in the navigator. Okay. That doesn't do anything. Select your target from the list on the left. Yeah, they must have just moved that menu to the top because that. Yeah, that's got to be. Okay, so click on it. Under the General tab, make sure the deployment target is set to an appropriate iOS version. Oh. Okay, so, okay. Build rules. Supported destinations. I got to add it here, brother. iPhone. This target will be updated to accommodate the new destination. Platform filters will also be set for its dependencies and linked framework. Source code will be unaffected and may still require changes. Well, all of them, brother. iPad, yeah. I'm actually really excited. I've said this to y'all before, but run your unmodified iOS app. The Apple Vision, I think, is gonna. I mean, not right now, but you know, maybe in the next release, or certainly the one after, I would think. It's already pretty sick what it can do, just in terms of. I mean, it's very limited, but it's really good. I mean, it's way better than some of that other stuff we've seen. You know, from those guys, Meta guys. That shit looks like it looks like Wii graphics. What were they thinking? Why would anyone want to go to that metaverse from, 2002? But anyway. Yeah, I think getting ahead of it is going to be a big deal. We're definitely headed to what's the name of that movie? Idiocracy. I think that's what it's called. People laughed, but hey, man. It's happening. It is happening. All right, supported. Okay, so I did that. So now I should be able to. God damn. Thank goodness. Yeah, so that's so strange. So what is. So there's this. Yeah, add this to the list of shit I don't like. I mean, there's like 50 million places to say you've added something. It's very confusing because you would think, okay, platforms that I want to develop for. Okay, I download the simulators. One might think, okay, I've done what I needed to do. It's local now. I should be able to use it. Wrong. No, motherfucker, you still gotta go. You gotta go up here and you gotta edit your schemes, and then you also gotta add the destination for the project. Which, to be fair, if I had already had these, maybe it would have offered to add these when I created the project. But still, you know, like I said, it's fun to bitch and moan. All right, so let's go back now to the book. To the book. Now we can get it popping. Okay, so choose. I don't forget what they wanted me to. For now, test the simulator program. From the scheme drop down, move to the iOS simulator. Okay, yeah. Okay, so iPhone SE 3rd gen. And then build and run again. Let me change this to, this should go on the bottom, I guess. Or why isn't it popping up? There's the simulator. Come on, dude. Oh, it crashed. That's awesome. Attaching Tawdoodle. Oh, there it is. Where the hell do I put it? I'll just have to pop in and out to it. Okay, I mean it's pretty. That's pretty cool. Must admit, it's pretty cool. Because you know, I mean, not everybody's gonna have the devices. They might literally just only have a Mac to do development, which was me for a little bit. What was I searching for? Key Pro? Yeah, Keystroke Pro. I think now would be a good time, or I'm going to try to put a more concerted effort on for myself, and by virtue of that, for you guys, learning shortcuts. I think it's a big deal. Because honestly, I mean, if I'm being realistic, I think it would be nice if I could write Swift in a different editor. But likely the best path is just going to be to get good at Xcode. So at the bottom of the screen now, you should be able to see my key commands. So at least you can get a sense for what it'll. Yeah, there we go. Okay. I see him now. All right. Whew. So we got that. I'm going to put this over here off screen until, damn it, it's not really a good spot for it. Can I shrink it? You can't, it's the actual size. Okay, never mind. We'll just switch to it when we need to. At least it's a separate app, so that's nice. All right, so build and run, and Xcode will launch the simulator app. If this is the first time you've launched simulator, it may take a while to initialize. Eventually, you should see the app launch, and we do see that. Hello, SwiftUI. Except mine has a cool little globe on it. Right now, Tawdoodle does not do much. It's time to fix that. Oh, shit. Let me get some water, bro. That is some view. To explore the components of a view, you will create your own. You will start with the view responsible for displaying the title of a task in the task list. Because remember, we're building a to-do app. Create a new file using file, new file, or command N. All right, command N. And select the Swift file template. Okay. Name the file taskview.swift. Taskview.swift. And all right. And make sure it will be saved in the shared group. Shit. task view. Is there like a, okay, good. Properties or something. File inspector. I'm pretty sure it is. I think it does that by default. Actually, let me, yeah, if I do a new file, targets tadoodle. Yeah, don't even ask you that. What do you, to the shared group? I guess we'll find out the hard way. If not, okay, so cancel that. All right, don't worry about it for now. Man, I really wish, oh, maybe it's in the property inspector. Okay, good, yeah, type. No. Location relative to group. Relative to project. Target membership, tadoodle. I mean, I assume it's shared. I don't see that term anywhere, but yeah, our guys are getting a little lax toward the end of the book here. Must have handed it off to the intern for the Xcode part, because it's not really, the details ain't detailing, as my lovely girlfriend would say. Yeah, let's see. What is meant by the instructor if we're being told to add a file to the shared group? I do not see that. I'm creating files. This context is particularly useful in projects with multiple targets. That makes sense, yeah. These are organizational units within your Xcode project that help you manage files. Groups don't directly affect the build process, but make it easier to navigate and organize your project. Okay, because, yeah, you would have differing views for, I mean, certainly for your views at the very least, your content views, since obviously iPhone and iPad and Macs all have different real estate to work with, different resolutions and whatnot. Steps to add. So we create the group. Create the group where you want to add the file. Create a new group. Right click. Yeah. Okay. After adding the file, select it in Project Navigator. In the File Inspector, look for Target Membership. Check the boxes for all targets that. Oh, okay. Okay. So that's, it's referring to the target membership off to the right. Grammars can't see it, everybody else can, but that's the tadoodle, and it's the only membership, so we're going to assume that that sharing would be inherent since there's only one group to possibly belong to. Okay, so now then, to explore the components of a view, you'll create your own. You will start with the view responsible for displaying the title of a tab. Oh wait, we did this part of SwiftUI, make sure. The file opens with a familiar import statement. Yeah, import foundation. Trying to get this to open here. All right. Import foundation. You will need to import the SwiftUI framework so that you can work with the elements it provides. So we want to get rid of that. Oh, and when you see sometimes you'll see the H and J I'm using the Vim motions in Xcode, so that's why that's popping up, but they're really quite handy. What we're doing, import SwiftUI. Nice. And then struct. So a value type, structs and enums, task view, and it is of type view. And that's it. And hold on one sec. I need to wash my hands. Ba-da-da-da-da-bamba. Ba-ba-bamba. Ah, 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 ah. All right. All right, cool. Now, SwiftUI struct view. A view is an instance of a value type that conforms to the view protocol. Oh, view is a protocol. Okay, good to know, good to know. Now, as you'll recall, we can hold Option key and click on something, and it'll take us to that definition, especially a Swift standard library thing. So let's check it out. So view, a type that represents parts of your app's user interface and provides modifiers you use to configure views. Overview. You create custom views by declaring types that conform to the view protocol. Implement the required body computed property to provide the content for your custom view. So here's a standard looking view. My view of type view. Inside the body, we have a single variable. So I assume that's the only requirement. Well, and the text too, but a variable called body. What was the sum? Damn it. Let me look, because that'll be important. I get it now. They're making a hint at what's to come. So this was a keyword for something, but it was, I'm almost positive it was relative to protocols, which makes sense because we are dealing with a protocol here. I just need a refresher on what it is. Protocols, where are you at? Properties, initialization, extensions, generics. There we go. You need a protocol and some conforming types. No. Some. Whatever. I should have just started here. So what in Swift? What is the some keyword used for in protocols? We did cover it though. I just opaque types. In Swift, the some keyword is used in conjunction with protocols to define opaque types. Opaque types allow you to specify a type that conforms to a protocol. Allow you to specify a type that conforms to a protocol without exposing the underlying concrete type. This is useful when you want to hide implementation details and only expose the interface defined by a protocol. What do you mean? So we wouldn't expose the underlying view from the standard library in this case. Here's a more detailed explanation. Okay, great. Basic usage of some. When you use the some keyword with a protocol, you're indicating that a function or property will return a type that conforms to the specified protocol. You're indicating that the function or property will return a type that conforms to the specified protocol. Okay. But you don't want to specify the exact type. I see. So instead of saying this type string will conform to the view protocol, we're just guaranteeing conformity, but not specifying whether it's a string or a bool or a, well, I guess a bool couldn't, but a string or some other type that we define, maybe an enum, a struct. This can make your APIs more flexible and easier to change without breaking code that depends on them. Why the fuck do they... I hope y'all can't hear that, but they're just going ham with the fucking weed whacker right now. We don't even have that much fucking grass out here. Oh, what are they? I don't know what they're chopping up for a fucking hour. God damn. Anyway. I gotta get over it. Defining an opaque return type. Suppose you have a protocol shape and several types that... It's almost like he heard me. He's like, ring, 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 ring. Now he's fucking revving it up. God, my gosh. But you know what? I'm blessed. I shouldn't complain. I'm inside in the cool air. It's hot as fuck outside, so let me shut up. All right. Suppose you have a protocol shape and several types that conform to this protocol. Suppose you have a protocol shape and several types that conform to this protocol. Okay, so we're defining a new protocol shape. And this would assert that in order to conform to it, you would have to have a method called area that returns a type double. Okay. And these would be structs that conform to it, as shown here and here. And they both have a method named area, returning type double. You can create a function that returns a shape without exposing whether it is returning a circle or a square. Circle and square being the types that we're saying conform to the shape protocol. You can create a function that returns a shape without exposing whether it's returning a circle or square. And we can do that by writing this function. So make shape returns some shape. Okay. I see. And you do... Oh, okay. So I guess it could... Because there's commonalities at the top level, you wouldn't necessarily have to change all of this, but you still might have to come change your implementation, but that's kind of your job as a developer. So, okay. So I get the convenience aspect. I'm gonna have to save this one. Yeah. So once we get through this chapter, I will then clean up this board that has all of our conversations with the Oracle about different confusing aspects, right? And then I will share this with you guys, and it'll just be it'll be additive. I mean, there's no limit to how many things we can put on here, and it is searchable. So we'll just put a different section on the same board, and we'll just keep adding to it. But just FYI on that. And then what were we? Sum. What is the sum keyword in protocol definitions? Opaque types. That might be, I mean, to my knowledge, I've never heard of anything else like that, but maybe Rust traits is like the only other thing like that. But yeah, Go certainly did not have anything like that. Not that I know of. I guess you could say generics is something like that, but yeah, whatever. Okay, so now that we know or have a solid reference point, we can stop living in the past and move forward, brother. Let's go back to that page. 710, was it? Yep. Wait, no, that's not. We were way ahead of that. We were here. That is some view. Okay. A view is an instance of a value type that conforms to the view protocol, which only has two requirements. Oh, that's the protocol itself. So this is what we are. This is how the view type up here is defined in the standard library. So public protocol view has an associated type body. Now see, now I done forgot. No, don't want to show me. Okay. Associated type. Let me just go to the developer docs. This is a good refresher, but these things take time. Associated type. Hey, man. Associated type. Right, generics. Okay, here we go. Associated types. Now that you know that types and functions, including methods, can be made generic, it is natural to ask whether protocols can be made generic as well. The answer is no. However, protocols support a similar and related feature, associated types. Okay. All right, let's explore associated types by examining a couple of protocols defined by the Swift standard library. The two protocols you examine are iterator protocol and sequence. Okay, I do kind of remember this, which together allow you to make your own types that can be iterated over in for-in loops. Okay. Associated type element. So any type and a func. Oh, okay, well, these protocols already exist in the Swift standard library, so you should not type them in. First, have a look at the definition of iterator protocol. Okay, so this example, we throw that bad boy on there. There you go. So this guy, associated type element. So we saw this, yeah, we did see this in generics, but you would type it like, you know, element after the function name. So here we just do associated type element. Weird. Oh, okay, that does make sense then. So the type can be anything. Well, this is the keyword, but so element would be replaced with string or struct or any type, I suppose. And then you would need this method along with it, and it just has to also return the same type that is the associated type, which just means these two need to be the same, but they can be anything. But on the mutating, it needs to be an optional because it could be nil. Okay, I vaguely recall. Yeah, okay. Iterator protocol requires a single mutating method next, which returns a value of type optional element. With iterator protocol, you can call next repeatedly, and it will reproduce, and it will produce a new value, a no value, a new value each time. If the iterator is no longer able to produce new values, next returns nil, which is why we need this to be an optional. Okay. Inside a protocol, associated type element states that conforming types must provide a concrete type that will be used as the element type. Okay. Yeah, so it can be any type, just not another generic or something non-deterministic. Conforming types specify what element should be by providing a type alias for element inside their definitions. What? Conforming types specify what element should be by providing a type alias for element inside their definitions. Okay. Yeah. Okay, here we go. At the top of your playground, create a new, okay. So this is that the whole? No, it's not. So that's part of it there. And then what is this? Struct. And here. Okay, so that's the example from the book, and then this is the Vue protocol by comparison. So then stack iterator wraps up a stack. Stack iterator wraps up a stack and generates values by popping items off the stack. The type of the element that next returns is T. So where's the what? Stack iterator. Yeah, so this is the generic. So this could take any type so long as it conforms to iterator protocol. Oh, I see the tie now. Okay. So this is what they meant. So yeah, type alias being the keyword for element, and then it would know what element is because the conformity to the iterator protocol, and then within the iterator protocol, element is defined as the associated type. So we just have to provide that and then give it a concrete type, which would be T. Okay. Okay, I mean, I think that's good enough. I just wanted to remember what that meant. So it can dictate where a concrete type should be, and then you have to name that when you use it. All right, that's good enough. Let's go back now. 725. Okay. A view, isn't it? Okay, we got there. When you learned about generics in chapter 21, better get rid of that too. You learned that the protocols can have associated types that must be defined by the conforming type. View requires an associated type called body that also conforms to view. This associated type is inferred by the compiler based on the type of the protocol's other primary requirement, a property called body. Okay, view requires an associated type called body that also conforms to view. Okay. You can ignore the @viewBuilder attribute for now. You will learn about it later. Okay. Public protocol view. Add a body property to satisfy the protocol requirements. All right. So in view now, we got var body as dictated by the protocol. And then some view, because we don't know what type. We just know it'll be a concrete type. So we say, or it'll be a type that conforms to view is what we're saying by saying some view. So var body, something, var body of type, something that conforms to view. And then this is the implementation of text that we want. Take out the trash. Hard coded for now, brother. All right. Errors went away. Okay, good. The text type is a view conforming struct defined in the SwiftUI framework. Okay. It displays non-editable text to the user and supports all the text features that you might expect, such as fonts, weights, and colors. Okay, non-editable. Yeah, okay. Here. I think I'll keep that one. Every view has a body that is also a view. Okay, every view has a body that is also a view. Okay. And you build a SwiftUI app by composing a view hierarchy of SwiftUI views. Yeah. I mean, it sounds a lot like cascading style sheets. Ever heard of it? Your own views and the relationships among them. A hierarchy of views with each of their bodies returning an instance of a different view conforming associated type can get very deep and complex. Yeah. To spare you the gritty details of deep view hierarchy types, the body property is declared as returning the some view opaque type. Yeah. Oh, I see. Yeah, okay. So then that would mean that your task view, if it did need to change, you wouldn't have to change it everywhere. At the top level, at least, you could just change the actual type that conforms to view wherever it may be in your code. But the top level struct wouldn't have to change at all. Because as long as they all conform to view, you know it's going to work. Okay. Cool. I get it. Spare. Recall from chapter 21 that an opaque return type allows an API developer to hide implementation details of the actual return type behind a protocol that it conforms to, while promising that the actual return type is stable across calls to the function. Yeah. To allow the canvas to display a preview of your view type, define a new preview provider conforming struct at the bottom of task view.swift. Okay, outside the task view's definition. All right. So here, a new value type, since it's a struct, task cell underbar previews. And it's of type preview provider. And you open up the body, bust it wide open. Oh, and it just opened up the preview window since it's a view type, so that's cool. And what's up in here? Task view. Okay. That closes. Wait, what? Struct task view of type view. Oh, I'm down here. I'm blind. All right, so close that one and then one more. All right. And static var preview. Static var previews. Some view. right, that don't have to do that, but my OCD is going crazy. All right, that should work. Cool. Okay, so we have a value type task cell previews conforms to protocol preview provider. We have a static var, so that was a type property. The keyword static means it's associated directly with your type. So in this case, if we were to call, even without any instance, we could, for example, print. We would have access to the value in this previews bucket, irregardless of whether or not there's an active instance of task cell previews, because we're making it a static type property via the static keyword. Okay. Resume. Wait, where's the little simulator? This should be, does it not work against this thing? Take out the trash. Maybe we'll get there. So I'll wait. Okay, but we got it here. So take out the trash. Okay. Preview provider enables a type to be rendered in Xcode's preview canvas. Oh, that makes sense. Preview provider. Xcode will search your file for a type conforming to preview provider and use it to generate a preview of the view returned by its static previews property. So whatever is in there. Okay. Oh, so that's neat. So you could pick and choose. Yeah. Okay. Here you return an instance of your task view type here. If the preview has paused, resume it to see the results. And if it is not visible at all, click the editor. Okay, well, we see it. So skip that. To change how a view appears, you can apply a modifier to it. Add some modifiers to your text instance to change its appearance. Oh, yeah, here we go. That's what I've been waiting for, brother. So where's this at? Add some view text. Oh, right beneath it. Okay. So inside of view, heavy memory usage. Do I need? I don't think I need the. Whatever. Let's just kill him, and then open him back when we need him, I guess. Yeah, I gotta say, just real quick, I bought this Mac. It's a MacBook Pro, 16 gig. It has the M3 Pro, so not the biggest chip, but the one below it. I bought it off some girl. She hadn't opened it yet. So I was like, oh, that's a steal. I mean, I saved like maybe 400 off retail, but it was good enough. Anyway, boy, do I regret it. I mean, I'm not saying it's a piece of shit, but it annoys me because like my Windows machine, my Linux box, those all have the max that those can hold, which is like 64 gigs of RAM. Apple, of course, since they don't let you upgrade it yourself, you got to spend a shit ton up front to buy their RAM. Anyway, I'm just saying, don't get, I would not recommend getting the 16. I have the 16. It's not like I'm slogging along, but I'm also not streaming from that machine for that reason, because of the RAM requirements, the simulator. It just fills up too fast. It's just not enough. Yeah, I mean, you could get by, but if you can afford to get 32, I would go 32 for sure, because, I mean, that shit's just, it's just annoying. That's all I can really say. It's just annoying. But yeah, there is some buyer's remorse. So the next time I get a Mac, yeah, it's not going to be anything less than 32, which I had a 32 before. I had the 16-inch, the M2, And that was plenty. I didn't have really any issues other than when I wanted to run like multiple Docker images, a VM, but that's crazy. But for this kind of thing, for the typical iOS dev workflow, 32. Yeah, so don't live in regrets, get the 32. Just shell out, brother. Just shell out. All right, so where we go? Oh, modifying text. Yeah, okay. Cool. So padding. Vertical. So these dots, just so you know, as we've learned, are indicative of we're accessing some property within the type itself. In this case, the text and or view type, because we would have access to both. So either under view or text, there is probably text. There are properties, or sorry, methods with these names. So that's where that's coming from. But that's why we hit the dot, because we're accessing something that's nested, a nested type or method inside of the text type. Padding, vertical, 50. Background. Color yellow. Okay. And font. Title 3. Cool. Okay. Modifiers are methods that return a new... Hold on. Mouth be dry, brother. Modifiers are methods that return a new type of view. Modifiers are methods that return a new type of view, creating a nested hierarchy. Okay. So these are modifiers. So they take the initial view, modify it, return it. And then this one modifies it, returns it again. Modify, returns it again. Okay. And modifiers, yeah, okay. Modifiers are methods that return a new type of view, creating a nested hierarchy. Here you apply the padding modifier to the text instance, which creates and returns a new view that contains the text as its child view. Oh, I see, yeah. As its child view, with 50 points of padding above and below the text. Okay. Then you apply the background modifier to the padding view, which paints the entire padding view and its child view, the text, with a yellow background. Then you apply the background modifier to the padding view, which paints the entire padding view and its child view, the text, with a yellow background. Okay. Last, you apply the font modifier to the background view, which creates and returns yet another view, applying the title 3 font style to the strings in all its children recursively, all the way down to the text instance. Yeah, literally like CSS. That's cool. And I assume we'll have blockers, whether or not we want to inherit rules around that stuff. So yeah, I mean, it's, to me, I mean, it's, browsers are so ubiquitous now. I think it just kind of makes sense, because what's it called? Android's version of this, the Jetpack Compose or whatever, they all use very similar concepts to CSS. So hopefully, I mean, if you know CSS, I bet this is going to make a lot of sense to you, or even if you just know how it works, So where were we? All this stuff looks so blobby to me. Okay, yeah, there we go. Figure 28.7 breaks down what you see in the preview. Note that the right-hand edges of the diagram rectangles have been artificially expanded to make it easier for you to tell them apart. The right-hand edges of the diagram rectangles have been artificially expanded. Oh yeah, I see what you mean. Because they're still, in all actuality, perfectly overlaid on one another, but to demonstrate it, they changed it. Fair enough. Okay, so let's take a look. So here's the initial view on the left. Let me get my pointer out, brother. That's what it's all about right here. Okay, take out the trash. And then this gets sucked in by padding, adds the padding, then makes the new view, and then so on and so forth. Background takes what it did, adds its stuff, spits it back out, and then font takes it. And then since it's the last expression in the scope, that would be the final view. But in effect, you can just take it in a procedural fashion. It's this, then it does that, and then you get all of the, you get the final result with everything combined. All right, so that makes sense to me. The order of modifiers is important because it affects the resulting hierarchy. Right, yeah. Yeah, that whole procedural thing is important to remember. It's happening in the order that you say it is, top down in the code. At least for, well, yeah, that's just how it is. But with visuals, it matters because it's going to depend on if some, it's the difference between something getting cut off or overlaid or misshapen, yada, yada. Modifiers are met. No, we read that last. You apply. Okay, yeah. The order of modifiers is important because it affects the resulting hierarchy. Move the background modifier to be applied before the padding modifier. Okay. Move the padding to be what? After the what? And move the background modifier to be applied before padding. Oh, move the wrong one. And background. Okay. What happened? Let's run it again. What the fuck? Resume preview. Okay. Now that the background is applied first, the padding view adds padding around the background view. Now that the background is applied first, the padding view adds padding around the background view rather than just around the text, as depicted in 28.8. I see. So here we're saying, here's the text first, apply the background to the text, then add the padding, then the font. Which, no, okay, that makes sense to me, yeah. It makes sense that the background coming later would apply it to everything versus just the text element. Okay. All right. Tracking. In both these hierarchies, the outermost view that is being returned, In both these hierarchies, the outermost view that is being returned by your body is the one returned by the font modifier, right? Because it's the last expression in that scope, which is generally the case anywhere you see that. If there's no if there's no explicit return, you can almost make that assumption with any language. Both these are. You can delete the background modifier and decrease the severity of the vertical padding, as both have served their illustrative purposes. Also, since task view is intended to display the title of any task, not just taking out the trash, give it a title property to display in the text. Yeah. All right, so in our task view itself, let title string, okay. Let title So a constant, aka immutable, cannot be changed once initialized. So a bucket, constant variable called, or constant variable of type string. Then we want to get rid of the title text. Just change that to title to pull in whatever's in that, going to be in that bucket. And then we want to get rid of background altogether. Okay. And change padding to 4. Failed to build the, oh right, we got to change something else down here. And then task view, now we have to pass it. Oh right, because the member wise initializer. So if we initialize something, we have to make sure there's a value provided for each property of that type. Title. Take out the trash. There we go. Now it updated. Okay. Since task view has a new property, its compiler synthesize initializer has changed to take title as an argument. Yep. Which is why we had to provide this. So you also update the task view initialization in the task cell previews struct. Yep. Displaying dynamic data. Oh snap. All right, it is fine to see previews that display hard-coded strings, but eventually Tadoodle should display user-generated tasks, not just one task, but a whole list of them. You need to define a type to model a task and a place to store a collection of them. All right. Define a task type in a new Swift file called task.swift. Okay, control N. Here. Task.swift. It's part of the main group. Create that. Okay. Command J to get into the editor. So we need foundation, so we'll leave that. We want a new struct, which is a value type with a single property, immutable property called title of type string. Your task type is very bare bones right now, but it will grow over time as the needs of your program evolve. Next, define a type in a new file named taskstore.swift that will hold and manage a collection of tasks. Your code will emit an error, which you can fix in a subsequent step. Okay, so taskstore.swift. Command J. Okay. Now we got a class. Oh boy. Class, which is a reference type. Task store. We have a private setter. Var task. Dang it. I need to get a refresher. What does that mean? What does this mean in the context of a Swift class? A private set var task. So it is a private setter, but a default internal getter. Code outside the class can read the value of task, but cannot modify it. Okay. This provides encapsulation, ensuring that the value cannot be altered from outside the class. Okay. Read, write inside the class. Code within the class itself can both read and modify the value of it. This allows the class to control how and when the value of the task is changed. Okay. So the setter is private, the getter isn't. So you can read it, but you can't set it. Oh, right. Okay. So, and that's why if you wanted it to be both, you could either do set get or just not do it at all, and that would make the getter and setter private. But if we just want the setter private, we do private set. Okay. Yeah, I remember that to a degree. Task, and so private setter for a mutable variable called task, and we want it to be of type an array of task, as indicated by the square brackets. And then we're saying that it will have a stored property of an empty array. So it'll just be initialized with an empty array. Then we have a method called add. Underbar ahead of the task here means that the parameter name will be anonymous, so we won't have to pass it. When we call this method, we won't have to pass it a parameter name. We'll just say add, and then whatever the value is inside it. We don't have to type a parameter name, which makes sense when it's, especially if it's like a mathematical thing like that. People understand what add means, so there's not much value in making them name the parameter too. So task, and then that'll be of type task. So this method, func add, anonymous task parameter, type task, with an implicit return type of task, perhaps. And then inside the body, here's the logic. So task, with an S. Append, which task is our empty array. So we're just appending individual tasks to that list of arrays. And yeah, so task.append, call the append method, add the task to the empty array. Task everywhere. Func remove, so it's a separate method, which makes sense because you want to make new ones, remove the old ones whenever they're completed, kind of a thing. Same concept here, task. And then our guard statement. So this is like saying we want to guard against this condition. So this, after the guard statement, the following expression needs to be true in order to proceed. Otherwise, just break out of it and return. So this guard let index equal task first index. Task dot first index. Why didn't I get my autocomplete there? Let's try it again. Guard let index. Am I looking at the right thing? Index equal task dot first index. Maybe they changed that one, but no, let me do it. Weird. first index of task, else return. Okay, so if index is equal to the very first index that's in that array, then we want to task remove at that very same index. So if the task matches up, then you can remove it. So it's some kind of check to make sure it's the correct one that we're getting rid of. At index. And oh, I guess it. Do I have to put a? I guess I have to put a space there. Nope, doesn't matter. Yeah, it doesn't like that. For what is this? What's it saying? Referencing instance method first index of on collection requires that task conform to. Oh, they did tell us what we'll fix the code. My bad. All right, so let me. Come on, brother. Okay. Remove at index. All right. When building more robust programs, it is common to build an abstraction around the collection of data that you will manage. One way to do this is with a store type. A store type. Okay. There is nothing special about a store. It is just, oh, buddy. Suddenly I have to take care of something. Y'all know the drill. Let me just, let's see, what time is it? BRB. We can go to the next break. So 30, what's it called? 210. It won't take long at all. 207. 207 CST. Yeah, be right back. Well, that didn't take nearly as long as I thought it might. All right. Okay. 732. Okay. Human readable size. And oh yeah, we're straight at the top. Okay. When building more robust programs, it is common to build an abstraction around the collection of data that you will manage. One way to do this is with a store type. There's nothing special about a store. It is just a name used to say, this is a type that encapsulates and protects data. Okay. That's a banger right there, brother. Let me go ahead and highlight that one. All right. The types users can only... Wait. The types users can only access the data the way I want them to. Oh, it's still talking. My bad. I cut off their quote. It is just a name used to say, this is a type that encapsulates and protects data. The types users can only access the data the way I want them to, and they don't know where I got the data from. That sounds like a lot of personality types that you encounter. Yeesh, yeah, okay. So we'll save that. For example, an even more complex app might abstract a networking layer and a disk persistence layer behind a store. Oh, yeah. Oh, yeah. So when I was working with, if you ever heard of a little project called Apache Spark, motherfucker, maybe you heard of it, also known as AWS Glue. You know, Amazon just takes all the open source shit, yanks it off, and then sells it for money. Motherfuckers. But anyway, and makes it more complicated somehow. But hey, what do I know? But yeah, that is a big part of how Spark is doing that under the hood. Yeah, okay. For example, an even more complex app might abstract a networking layer and a disk persistence layer behind a store, so that users of the store do not have to think about the source of the data they are accessing. Yeah, that is a really nice abstraction that is common and appreciated. This strategy or pattern is a stylish way to ensure that the data is never manipulated in unexpected ways. Yep. Task store is a simple store type that owns an array of task instances and makes the setter for that property private. Okay, so setter for the property private. And it owns also the ways that we can add data or remove it. Okay. This ensures that the only way for another type to change the list of task is through the store's add and remove methods. I see. So since these are not private, the methods, but the setter is, then the only way, well, the setter for this task array is private. So the only way to affect it is by calling these exposed methods on the type. Okay. So even though, so even though this is a var, we couldn't access it from a different type outside of this one to change it. Yeah. All right. This code produces an error referencing instance method first index of on collection requires that task conform to equatable. Right, that's what we got over here. The reason is that the first index of will perform an equality check to compare its argument to each instance in the collection. That makes sense. That's what we're doing here. Yeah. In the collection, and it will return the index of the first instance for which the check returns true. Oh, okay, yeah, that makes more sense. I was thinking it meant first in the array, and I'm like, that's kind of, but okay, that makes sense. So searching for the first match, and then, because index would be, a value, let's just call it 1, and then it would scan the array for the first index that matches 1, because that's what we're saying of, like whatever the index is what it would compare to. So this would be the same value, index and task. So it searches for the first index of that. If they match, then we know that's the correct one to remove. If there is no match, then we break out. We don't do anything. We just return. Okay, that makes sense to me. Yeah, so... okay. The reason... and it will return the end. Yeah, fair enough. Make your task struct equatable. Struct task. Task.swift. Wrong file, brother. Okay, here. So we need it to conform to the equatable protocol. So equatable, that's how we do that. And then, as you learn in chapter 25, merely declaring conformance to equatable is enough if you want the compiler to implement the required equality operator for you. Right? Meaning it'll synthesize it for you. You don't have to write that code. But when you build your app, the compiler is doing it for you. You have not developed any views to allow a user to enter tasks yet, but it would be nice to see some sample data in your previews and when you run the app during development. At the bottom of the taskStore.swift, outside the class's definition, use an extension to define a static property holding a sample instance of a task store populated with hard-coded data. To save on labor. Okay. I'm never going to get the video out of my head. Taskstore.swift. Pop over there, brother. If. Wait. Pound if. If debug. Extension. Task store. So if we're in debug mode, apply this extension to task store. Is that what we're saying? And okay, so we have a type property as indicated by our static keyword, meaning it'll be associated with the type and we can access that property irregardless of whether there's a active instance of said property or not. And this will be of type task store. Okay. And it'll have a property task. Oh, I see. So we're giving it an array of data that it can always have access to. Why is that? Oh, my bad. Okay. Comma there. And task, title, fix, capital, fix bugs, and task, title, shape it, ship it, bop it, twist it, pull it. Yeah, only millennials will know. All right, and then we have let store equal task store. Actually, that might, Gen Z might think I'm talking about something else entirely, brother. I wasn't. Just forget I ever said anything. Store task. You know what's crazy? I used to think we were nasty when we were young, and then you see some of the shit this new generation be on, brother. Yeah. No. Whole new level of nasty, man. Store. End if. What is this, bash, brother? End if. All right, so if in debug mode. Kind of like that, actually. It'd be cool to have scoping like that, but I guess you kind of do with text with the triples, whatever. Anyhow, very little of this is new. You have defined extensions. You have worked with static properties. You have created variables whose initial values are assigned to the result of calling an inline closure. You've created value. Blah, blah, blah. You've created variables whose initial values are assigned to the result of calling an inline closure. Correct. We have seen that. Which would be, what was that? Var something. And then like a trailing closure. And then index in, and then some logic. Something like that, yeah. Okay. I do recall. Go up one, get rid of that. All right. You do all these things here to create a sample instance of task store that you can use as dummy data. You can use as dummy data during development. The new syntax is pound if debug and pound indif. These compiler control statements allow you to specify chunks of code that should only be compiled into your program under certain conditions. Oh, that is cool. Go ahead and save that, brother. Wait, I just need this part. Just let me drop a little note there, brother. Compiler control statements. All right. Notice that the compiler control statements do not create braced scopes. The conditionally compiled code is between the lines containing pound if, pound indif. Yeah, I did notice. In this case, the condition is that you are building. In this case, the condition is that you are building for debugging as opposed to building to release your app for distribution. Okay. Recall from your error handling work in chapter 23 that the assert function only checks its condition when debugging, right? Now you know how. What does that mean? Oh, like, okay, so when you write assert, the compiler ends up writing whatever it synthesizes, it ends up creating this scoped block here, a compiler control flow for you, I believe is what it's saying. In this case, the condition is that you are building for debugging as opposed to building to release your app for distribution. Recall, oh wait, we're in there. Using these compiler control statements, actually, sorry, I gotta ask because I want to make sure that's correct. Automatically download and install. Yeah, I guess. Oh, that was fast. All right, cool. So in Swift, when you use, let's get bigger. No, it can't. When you use an assert statement, is the compiler generating said code in a if and if? In summary, it's conditionally compiled based on the build config, which is managed by the compiler, rather than requiring explicit. Okay, no, I didn't get my question, but I didn't really ask it that well. Instead, we'll just give it this chunk and let it flex its muscle. I would like to know though, so yeah, you will answer, brother. Let's see. The please expound. The bigger the word you use with it, it give you a smarter answer back. Not really. Please expound on the below passage on SwiftLang. Okay, conditional. God damn. Okay, so yeah, the answer is yes. All right, I don't need to read all of that. All right, in this case, the condition is that you are building for debugging as opposed to building to release your app for distribution. Recall that from your error handling work, that assert function only checks its condition when debugging. Now you know how. Using these compiler control statements, you can ensure that your sample data does not accidentally ship if you distribute your app to the App Store. Yeah, that's funny. I've seen that before in an app. Asked the dev about it, and they promptly fixed it. But yeah, so that's interesting how that can happen. Maybe they didn't have it back then because that was years ago. He would have been using Objective-C probably. Since SwiftUI Canvas previews and simulator both execute your code in debug mode, you can use the sample data as much as you want. Oh, that's good. Since SwiftUI Canvas previews and simulator both execute your code in debug mode, you can use this sample data as much as you want while you're developing your app. By the way, the warning and error expressions that you met in chapter 24 are examples of another type of compiler control statement called a compile time diagnostic. Okay. Later, you will let the user enter their own task, but for now you have a collection of sample tasks to display in a list. Now that you have created a SwiftUI view from the ground up and have studied its constituent pieces, you are ready to use Xcode SwiftUI view file template, which you can access from the File, New File menu item or with Command N. Use it to create a new SwiftUI view in a file named Task List View. All right. Oh, how about that? I didn't even see it down there. SwiftUI view. Okay. Next. Oh. That's silly. SwiftUI view. And task list view. Oh shit. Yeah. Wait, that looks like the one from before. I guess it doesn't matter what it looks like, but how it writes. But yeah, I mean, it does look like the one from before. SwiftUI view. Oh, it gave us this. I thought we were looking at the same file. Let me make that a little smaller. Okay. I think we literally wrote that though. Yeah, we did. Oh, I guess you can, if you just pick it, it would just give you this versus a Swift file. But they're both just .swift. Okay, my bad. I see. So it'll template it for you to an extent. Now that you have created, okay, we did that. SwiftUI view. The template sets you up with a struct that includes the required body property as well as a second struct that conforms to preview provider. Conforms to preview provider. I guess with this syntax, we haven't seen that yet either. Task list view will be responsible for displaying a list of task view instances. Fortunately, SwiftUI has a built-in view type called list that would do nicely. Thank goodness. From the body of task list view, create a list and populate it with some task view instances. Create a list and populate it with, okay. Task list view is where we be. What do you want me to do? In text. No, just blow away the whole thing. Some view, and then you want a list. And it'll be task view. Yeah, title. Take out the trash. Title. Do the dishes. And task view title. Learn Swift. Okay. That strange list creation syntax is using a view builder. That strange list creation syntax is using a view builder. I wonder why they call it strange. Maybe because that's, I don't know. In JavaScript, you do this all the time, and it looks almost identical, but just different keywords. But yeah, I guess it'd be strange if you never saw that. Remember the @view builder attribute on the body property in the view protocol requirements list? Yes. Yes. uh, okay. Babe. That view protocol. Computed properties and function parameters of closure type can be marked with the @view builder. I'm a little annoyed, but okay, I understand. Closure type can be marked with the @view builder attribute to allow syntax like what you use here. A new line delimited instead of a comma delimited list. I see. Oh, so that's what okay. Let me read that again. The strange list creation syntax is using a view builder. Remember the @view builder attribute on the body property in the view protocol requirements list. Computed properties and function parameters of closure type can be marked. Oh, I see. So, okay, I want to go look at it then. Where was that? Content view. Or no, it was in we didn't write it. It was just showing us what the protocol looked like. The view protocol. Yeah, this one here. So they're saying you can do this. So the property wrapper. Let me go back. Whoa. Okay, remember the computed properties and function parameters can be marked with the view builder attribute. So is this... I wonder if... view builder, a custom parameter attribute that constructs views from closures. Result builder struct view builder. You typically use view builder as a parameter attribute for child view producing closure parameters, allowing those closures to provide multiple child views. For example, the following context menu function accepts a closure that produces one or more views via the view builder. One or more via the view builder. So a generic function called context menu. It takes some type, any type that conforms to view, and then uses the attribute view builder, applies it to menu items, which is a closure that takes, or it's of type this kind of closure. So it takes a closure as its argument, and it needs to return type menu items, and then ultimately the function itself should return some opaque type that is going to conform to view. Okay, clients of this. Okay, my view, and it's just showing us. All right, clients of this function can use multiple statement closures to provide several child views without doing the comma delimited. All right. So what I would like to ask is if this in Swift, please explain the if there are, or wait, is a, what do they call it? Is a attribute in a SwiftLang protocol. The equivalent of a property wrapper. If not, how do they differ? Okay, attributes in Swift are used to provide additional information about declarations or types. They modify the behavior or provide metadata to the compiler. Usage attributes are applied to types, functions, variables, or other declarations. Oh, so they can be used everywhere. At available. Okay. Property wrappers. Purpose. Property wrappers provide a way to encapsulate the behavior and logic that you want to apply to properties. They allow you to define custom behavior for properties, such as adding validation, lazy initialization. All right, so this was to control either on the ingress or egress whether or not you want to do something to said property, whereas attributes, they provide additional information and they can modify behavior or provide metadata to the compiler. Okay. Man. All right. That is a lot of stuff, but that's cool. So what is it saying then, now that I know what it is? Remember the computed properties and function parameters of closure type can be marked with the attribute to allow syntax like what you use here. A new line delimited instead of comma delimited list. Okay, so that's what ViewBuilder is. It lets you define the list in that way. Okay, I gotcha. Yeah, that's really nice actually. Yeah, I swear, Swift just sounds like a DSL machine, to be honest with you, which is good. I mean, it's not a bad thing, but SwiftUI views that are automatically collected. Oh, it was a continue. I thought that was the end of the sentence. Syntax like you use here, a new line delimited instead of comma delimited list of SwiftUI views that are automatically collected as children of the type the closure is passed to. Here, 3 task views, over here, 3 task views are collected and made the children of the list. Okay. Task view. Cannot convert. Why am I getting these errors here? Associated type. Oh, because I left this here. That's, yeah. Okay. Get rid of that there. Oops, okay. All right, what is the problem? Okay, good. Now it went away. All right. The complete signature for the list initializer that you are using here is init at viewbuilder content, and it's of type closure. So empty tuple returns type content. Okay. Content is the generic placeholder for the type of the list content view. You are passing a view builder closure to the list initializer using trailing closure syntax. Yeah. Var body some view. Oh, right, because that's what that be. Trailing closure syntax. Okay. Your preview should look like the kind of simple list you might have seen in other apps. And it does. It does look like that. See that? All right. Can I pan the screen here? No? Can't do it? Okay. You should preview the kind of, so yeah. View builder syntax for composing views is very cool, but this data is insufficient. You want to display the task from the task store. Give task list view a task store and give the sample data to the preview provider. Give task list view a task store and give sample data to the preview provider. Okay. Task list view now needs a store. Var task store, and it is of type, task store. Okay. In our task list view, struct task list view, underbar previews, where's that at? Struct task list underbar previews, preview provider. Static bar. That's not the same file, is it? Sure isn't. Okay, task store. Here. No. Where is that struct task list views? There it is. Task view. Some view task store. Oh, instead of task view title. Okay. So now we're creating an instance of task view, and we're feeding it the sample data. Task store. What's the what? Replace task store with title. I must have missed something back here because and if or they skipped a part. When did we change it to title? Task store, task list view. So we have task list view, var task store. Okay. Maybe I was supposed to add that back. Task list view. No, that's what I got right there. Bar, yeah, some view preview. I don't know about that, really. You want me to get rid of, maybe, I don't know, did you forget to cross that out? Usually it will explicitly tell you when they're removing something and what you're replacing it with. But if we go back to when we created task list view, when was that? Task list view here. Okay. Task list view. I don't know where this came from. Why did I put that there? That should have gone somewhere else, it looks like. So that's my bad. Where did I even see that shit? Pound preview. Weird. Okay. Losing my mind. Definitely losing my mind. Equatable. It's not down here. There's if debug. Static. End if. No, we got all that. Weird. Where the hell? Yeah, okay. I don't know. I don't know where I got that from. Task list store. So it has to be this then. And this should just go back. Maybe. Task list view. Oops. Dot sample. Well, that worked. Yeah, I don't know where the hell I got that from. Maybe that's a sign bumping up against the wall today. But let's see what's next. So task store sample. Okay, so that's working. Now you're ready to iterate over your array of tasks and create views for them. Now you're ready to iterate over your array of tasks and create views for them. SwiftUI has a view for this as well. Use a for each instance to unpack your task into task list view instances for the list. This will generate an error, which you will fix shortly. Okay, task list view again. We're getting rid of, oh, okay, cool. How much is left of this? Ooh, goddamn. Okay, a lot. Yeah, okay, so I'm waiting a bit here. I'm really curious where the hell I got that from. I guess I grabbed it from the Oracle's output. Shoot, I don't know. But either way, we're going to wrap it here, guys. We'll pick back up. I think I'll start it back from... I won't proceed further into the book, but I'm going to look back and see what the hell I did. And then we'll start back up at the same spot tomorrow, basically at this point, when we created the task list view using the SwiftUI template. That's probably a good spot because there's quite a bit left, so no reason to try to force it in today. All right, guys, so thanks for coming by and checking me out. Checking out SwiftUI. Make sure you come back. As always, we'll be on tomorrow at 11 a.m. Central Standard Time. And also, don't forget to check out my other stream, 9 p.m. Central Standard Time. 100 Days of Ranked Halo. Today is day 71. Road to Onyx. And I'm currently at Diamond 1 in Ranked Snipes and Ranked Arena. So one of the two, we're going to get it there. 9 p.m. Central Standard Time. Make sure you come around. All right, and drop a sub, will you? Quit being stingy, brother. drop a sub. And I'll see you guys a little bit later or tomorrow. Take care of yourselves. Go eat lunch. I haven't eaten lunch yet. I need to do the same. Hydrate and hug one person today. Okay. Goodbye.